Hi everyone, welcome back to my channel, and today I'm going to be talking about Euler's number. We'll be covering what is Euler's number, some facts about Euler's number, how to differentiate Euler's number, and some practice problems. So let's begin. Let's take the function 2 to the power of t. We can't differentiate this using the ordinary techniques of differentiation, but we can do the derivative of this by using the definition of the derivative in terms of the limit. If we do, we'll get this expression. And this expression is really unique. Why? Let's take 0.0001 and put this into the function. The first 4 to 5 digits will be the same as if we input 0.000001. This isn't very unique, but now let's take something else. Let's input one number that will give us 1.000, exactly 1. Well, mathematicians define that number as Euler's number, as in an approximate as 2.71828. So now that we've discussed what is Euler's number, let's look at some facts. Euler's number is used in a variety of purposes, such as engineering, science, and mathematics. So let's take some unique examples. X squared times e to the minus x. The area of the curve is 2 factorial. X cubed times e to the minus x is equal to 3 factorial. X to the power of 4 times e to the minus x is 4 factorial. Well, the 2's, the 3's, and the 4's match with each equation. So what is a factorial? A factorial is just each number multiplied till 1. So if it's 4 factorial, that equals 24, such as in 4 times 3 times 2 times 1. We won't do times 0 because that will just give all of 0. So 4 times 3 times 2 times 1 will give us 24. So now that we've discussed our first example, let's do our second example. Did you know that the derivative of e to the power of t is just e to the power of t? So if we were to define something as the distance of e to the power of t, the derivative of that is e to the power of t, which is the velocity. The derivative of that is e to the power of t, which is the acceleration. And the derivative of that is e to the power of t, which is the jerk. So now that we've looked at both examples, let's talk about how to differentiate this. So let's take, for example, the laws of exponentials. So e to the t plus dt is just e to the t times e to the dt. If we do, e to the x minus y is just e to the x times e to the minus y. And then one more identity is that e to the minus x is just 1 over e to the x. Now that we have discussed the laws of exponentials, let's actually now look at how to differentiate them. So let's take e to the 4x. Now, if we were to differentiate this, take the coefficient of whatever we have, then multiply to the in front, and then we get 4e to the 4x. And this is how we solve this. Now let's do a second one. So let's do 7e to the 6x. If we do this, take 6 multiplied by 7, and now keep it. So it'd be 42e to the 6x. Now let's take one more unique example. Let's take e to the x squared. If we do this, we will get 1 times e to the x squared over e to the x squared. But notice, since we have a power which has a power higher than 1, we can now differentiate x squared too, which is just going to be 2x. So if we multiply by 2x, we'll have 2x e to the x squared. And boom, this will be our answer. So now, let's look at some examples. So we have discussed how to differentiate some functions. Now let's look at some more examples. So let's use one for the product rule. So let's talk about the formulation for the product rule. U prime v plus uv prime is the formulation, as in u prime v plus uv prime. So now let's have t squared times e to the power of t. So the second one is always going to be u, the first is always going to be v. We can note this down physically or mentally, but I like to write it down physically if it's going to be a harder problem. So e to the power of t, take the derivative of that is just going to be e to the power of t, and then t squared, take the derivative is just going to be 2t. So now, let's work this out. If we do work this out, we're going to get, so first we're going to get e to the t times t squared plus e to the power of t times 2t. we can factor out an e to the power of t. If we do this, we will get e to the power of t times t squared plus 2t. And this will be our answer. So this is one equation that we can do. Now let's talk about the second one that we're going to do. So there's something called hyperbolic functions. They're just the trig functions for hyperbolas, which are just like parabolas but different. So let's talk about those functions. So we have sine h, cosine h, and tangent h. The derivative of sine h is just cosine h. Now this gets a little interesting. The derivative of cosine h is just going to be minus sine of h. But the interesting part is we don't have a minus. It's a plus sine of h. This is because we're doing with hyperbolas, not circles. So it's positive sine of h. Then the derivative of tangent of h is going to be secant squared h, or secant h squared. So now, these are all the derivatives for hyperbolas. And now, let's do one more example before we wrap up the video. So, let's do sine of h over inside cosine of h of x. And remember, this is not the product rule. This is something different. It's called the chain rule. So what this means is take the outer function derivative, keep the inner function, multiply the derivative of the inner function. So let's do this. The derivative of sine of h is just going to be cosine of h. Now copy this down as in cosine of h of x. So now multiply this by sine h, because that's the derivative of the inside. So now if we were to do this, we would get sine h cosine h of cosine h of x. And this would be our answer. Today we have covered what is Euler's number, some facts, how to differentiate, and some practice problems. Thank you for watching this video, and thank you for watching my channel. If you would like more videos, please subscribe to my channel. Thank you.